Today's lesson is on relations. This is part one of a two-part lesson. So first of all, in math, a relation is a rule for pairing numbers together. Based on this definition, you will see pairs of numbers, which are called ordered pairs. We worked with ordered pairs when we were graphing points on the Cartesian plane. So sets of numbers or pairings can be presented in several different formats. It could be a table of values, ordered pairs, on a graph, or even as an equation. We're going to see the equations for our next lesson. But first of all, let's look at an example. Here is a table of values. We have the X column and we have the Y column. These all create ordered pairs. And there is a relationship between the numbers in the X column and the numbers in the Y column. Can you see what that relationship is? The numbers in this column are 4 more than the numbers in the X column. So we summarize that the Y values are 4 more than the X values. And if you move down on the sheet, give us a chance to focus, you will see that the corresponding list of ordered pairs is the 0.15, 26, 37, 48, as well as 59. I have created a Cartesian grid. A scale of 1 has been used. Sorry, the numbers didn't show. And again, on the y-axis, there is a scale of 1. And using our skills of plotting, this point is 1, 5. So you go 1 on the x-axis, and then you move up to a 5, and then you plot a point. And again, 2, 6, 3, 4, 3, 7, 4, 8, and 5, 9. And given that the numbers all line up, we can see that there is in fact a pattern. And I expect that pattern because I'm following the rules. Now, the numbers in the first column for X, these values are often called the independent numbers because X is the independent variable. You are in control here. You get to choose the values that go in the X column. Now, for the Y values, these numbers are dependent on X. So the number that correspond to Y, Y is called the dependent variable. You do not choose these numbers. They are found by applying the rule and the values from the X column. So following our rule that the Y values are 4 more than the X values, the next number in our ordered pair would be 6, 10. So I increase the X value by 1 to a 6, and the Y value is 4 more. So it's the ordered pair 6, 10. There are infinite pairs and numbers that apply to this rule. So keep that in mind. There's always lots and lots of pairs. As a challenge, can you think of the equation that applies to this relation? The answers at the end of the lesson. Now, we're going to look at one other example, and this time I've included a fraction. So what we're going to do is we're going to create a set of 5 ordered pairs where the y coordinate is half the x coordinate. Now, half is the same thing as dividing by 2. So keeping that in mind, it's a good idea to choose the x values that are even numbers. Because when we take an even number and we divide it by 2, we're going to get a whole number, and we're totally going to avoid the fractions and the decimals. I think it's important that you choose values for x that convey a range of numbers. So I am including an x value that's negative, as well as 0 and a few positives. Generally, you always want to pick a minimum of 3 ordered pairs. 5 is even better. So now that I've chosen my x values, I know the first part of the ordered pair. So now I have to figure out the corresponding y value for each pair by applying the rule. Okay, so half of -2 is -1. Half of 0 is just 0. Half of 2 is 1. Half of 4 is 2. And half of 6 is 3. And so down below, we have summarized all our ordered pairs for this particular relation. And I have graphed those relations on the Cartesian grid. And again, there is a scale of 1. It's very faint on my copy here. And so there's the first one. Oh, sorry, -2, -1, 0, 0, 2 and 1, 4 and 2, 6 and 3. And again, these numbers are all lined up. In fact, if we were to connect them, they would form a straight line. And so we can describe this relationship as being a linear relationship. Now, based on this pattern, can you find another point or an ordered pair for this rule? You can pick another possibility for x. So I could choose x is 8 and half would be 4. And then I could also see that when I plot that point, it does indeed follow the pattern that we have been working with. And that is working with relations.